So Al-Sufi proceeds with the equivalent expression. This is, I think, also on page 70 of k is equal to 0 all the way to n of m choose k times n choose p minus k. And this expression, he says, applies for the following situation. So p must range from 1 to 16, and n is equal to 4, and n is equal to 12. So the equivalent of this expression for Al-Sufi would be, would be in general, not for Al-Sufi, but to present this would be the following. The summation from k is equal to 0 to n of, let's replace each item, m as 4 and n as 12, right, in the previous expression, and see what we get. So it's 4, choose k, right, which is one number, right, for each of these terms as it goes from k is equal to 0 to m, and remember n was 4, right? So 4 choose k times n, which is 12, choose p minus k, right? P, let us keep it general here, p minus k, right? And k travels all the way from 0 and increments up to m is equal to 4. So we should get 0, 1, 2, 3, 4, so 5 terms altogether, right? So what would this actually mean? This is 4 choose 0 times 12 choose p minus 0. That's my very first term, right, when k is equal to 0. And you add, because you have a summation sign, you add the next term, which is 4 choose 1, because k is now 1, it's the next incremental term, and 12 choose p minus k, right? What was k? In this case, this is 1, right? So p minus 1. Similarly, you get the next term, 4 choose 2, because now k is 2, and 12 choose p minus 2. And you get the third term as this. The fourth term is 4 choose 3, and you have 12 choose p minus 3. And finally, you have 12 choose, you have 4 choose 4 times 12 choose p minus 4. So you can see, once you insert the equivalent number for p, so say p is 12, for instance, you would have 4 choose 0 times 12 choose 12, right? 12 choose 12 is just 1, because n choose n is 1, and 4 choose 0 is 1 as well, right? Because 4 choose 0 is factorial 4 divided by factorial 4 minus 0, which is factorial 4 again, times factorial 0, right? And 4 and 4 cancel, factorial 4 and factorial 4 from the numerator and denominator, right? So this term and this term give you 1, and factorial 0 is 1 as well. So 1 divided by 1 is just 1. So the very first part of the first term and the second part of the first term both give you 1. So this would be 1 if p were to be 12. And in this case, you can see what it would be. It would be factorial, it would be 4 choose 1 times 12 choose 11, because p is 12 minus 1 is 11. And that would be in the next term. Similarly, you can work it out for any p. And he says p ranges from 1 to 16. So you can probably do an exercise and choose your p and work out this term. All right? So this was one exercise that we covered. And then again, we need some more mathematics on page 73 and 74. We do need something that looks like the following. Un is equal to 2 un minus 1 plus 1. Now what is this? This is a recurrence formula. That means u sub n, which means the nth term is related to the previous term, the n minus 1th term, in some sort of recurrence relation. Now this is a very fundamental idea in mathematics, but I think it's also a very fundamental idea in Sufism. And it might be where the two areas meet, and that's what the three Sufis are talking about, the three great Sufi mathematicians are talking about. And on page 73 as well, Al-Sufi talks about UN is equal to the following. K goes from 1 to n of n choose k. We've met this before, right? So this is familiar. And on page 74, he says that this can also be written as the following breakdown. N minus 1 choose k minus 1 plus n minus 1 choose k. So n choose k should be equal to the sum of n minus 1 choose k minus 1 plus n minus 1 choose k. And this is a theorem, he says, from 1 all the way to n. This is a theorem that can be worked out. But we leave the proof to you, but what we can do is unpack what this actually means, the left-hand side and the right-hand side. So the left-hand side is just factorial n divided by factorial k times factorial n minus k, which is just the definition of n choose k. We can use the very same definition, but every time pictorially we see n, we replace it with n minus 1, and pictorially whenever we see k, we replace that with k minus 1. So what is the first term on the right-hand side? That's n minus 1 factorial divided by k minus 1 factorial times n minus 1 minus k minus 1 factorial. So this looks a bit untidy, but that's funnily enough just the first term. It's the first term of the right-hand side. So you have to add the next piece, which is n minus 1 choose k. What is that? That's n minus 1 factorial divided by k factorial times n minus 1 minus k factorial. And basically, if you manipulate all this, then you actually do see the proof that this is indeed n minus k. All right? How would you go about that? You go about that by just unpacking each term, the definition of each term. What would that mean? Let's just work out the first part of the right-hand side, which is what is n minus 1 choose k minus 1. Right? It's just algebra. So that is n minus 1 factorial divided by k minus 1 factorial times n minus 1 minus k minus 1. And the whole thing factorial. Right? Oh God, gone on to the table. That is n minus 1 times n minus 1 minus 1 all the way to 1. Right? So it's n minus 1 times with 1 less than the first number, times with 1 less than the first number. You keep doing that until you get the smallest number, which is just 1. That's my numerator. What's my denominator? It's k minus 1 times k minus 1 minus 1, etc., all the way to 1, and then times with this complicated mess, which is, if we open this up, this is n minus 1 minus k plus 1. So plus 1, minus 1 and plus 1 cancel. So it's actually n minus k factorial. Yeah? What is that? Let's copy the numerator in its equivalent form. And the denominator has this piece, all the way to 1, times the second piece, which is n minus k times n minus k minus 1, etc., all the way to 1. But you can see that there will be some amount of cancellation, but when you join the second piece, which is n minus 1 choose k. So the first piece was this, the second piece was n minus 1 choose k, which means n minus 1 factorial divided by k factorial times n minus 1 factorial, right? Sorry, n minus 1 minus k factorial. So this term is n minus 1 minus k factorial. What is that? That is n minus 1 times n minus 1 minus 1, which is n minus 2, all the way march up to 1. And in the denominator you have k factorial, which is k times k minus 1, etc., all the way to 1, times n minus 1 minus k as my first term, n minus 2 minus k as the second term goes on, right? Now, if you combine these two, that means you add this expression at the bottom to this expression at the top, right? You can find that there will be some common factors. What would be common? Look at the numerator. The numerator for the first term, first part of the first term, is the same as the numerator for the second part of the expression, yeah? It's n minus 1, n minus 2, all the way to 1. And then part of the denominator is also common. K minus 1, K minus 2, see, K minus 1, etc., etc. K minus 2 would have been the next term. So they're all in common, right? And take n minus k minus 1, that's in common as well with the second term. So all the common factors you can group together, and whatever remains can be simplified algebraically. And funnily enough, if you add these two expressions together, you will get n choose k. We can do that as an involved exercise, but maybe I can scan it and send it off. But so far so good. We can move on to the next idea. And the next idea is, let's see, the next time there's some mathematics on page 74. Some of it is familiar, and I won't go over that again. But you have n choose n plus r is equal to 0. So what is the proof of that, or what is the meaning of that? That just means factorial n divided by factorial n plus r times n minus n plus r in brackets, and the factorial of that. But does that mean anything? See, that these are positive numbers, factorial n and factorial n plus r. These are positive numbers. But what is factorial of a negative number? You have n minus n, which is 0, and remember there's a minus sign here, so if that's in front of the brackets for n plus r, you get a minus sign ultimately remaining, minus r, right? So minus r factorial, but that doesn't mean anything really, and that's 0 rather, okay? So that is 0. Also, what is n choose n? N choose n means factorial n divided by factorial n times factorial n minus n. This is 0, so factorial 0. Factorial 0, remember, was just 1. And factorial n divided by factorial n is the number divided by the very same number. So these give you cancel to become 1. And this is 1. So this is fundamentally 1. But n choose 0, what is that? That's factorial n divided by factorial 0 times factorial n minus 0. And that too is n factorial divided by 0 factorial times n factorial. This cancels to give me 1. 0 factorial is 1 as well. So this fundamentally equals the same thing. Alright? And the final piece of mathematical notation is in the form of a to the k n is equal to factorial k times n choose k. Now, if you just unpack what that means, I'm just writing factorial k like it is, and I'm replacing the expression for n choose k, which is factorial n divided by factorial k times factorial n minus k. Okay? Conveniently, factorial k and factorial k in the numerator and denominator cancel, leaving me with the following number. And that's exactly what is stated in the paper as well. So luckily, if you're home safe, this is all the mathematics that at least externally appears in the paper, or most of it at least, and it's all fulcrumed on the binomial theorem as well, because n choose k, summation of that, those are the coefficients of the binomial theorem. And you might take a look because that's given in tutorial 1 and in the first YouTube video. And maybe this would help unpack some of the ideas behind the paper, which was to show the emergence of one from the other, a recurrence in the very nature of mathematics and in the very nature, perhaps, of the one, of God.